Welcome to section 15.8, the square root property. So here you have an example of an equation, 25x squared plus 6 equals 10. So it's going to be very similar to solving an equation, but it's going to involve using the square root property. And you want to see what I mean by that. So let's start working on this example. So the goal is to get the x squared by itself, just like any given linear equation. You want to get the variable by itself. So the first step is I want to cancel out the 6 from the left side, so I'm subtract 6 on the left, therefore subtract 6 on the right to balance. I'm going to have 25x squared equal 10 minus 6 will be 4. After that, I'm going to divide both sides by 25 so that I can get the variable by itself. So we have x squared equal 4 over 25. And there's nothing you can do to simplify the fraction because there's nothing in common between 4 and 25. So now this is very similar to what we had in 15.1 when you're trying to find the principal root and the roots. So in order to solve for x squared, the opposite of x squared is the square root. So if I'm going to do the square root on the left side, I'm going to do the square root on the right side. So what we're going to have here is x equal, and since we have the square root of fraction, you can rewrite it as the square root of the numerator, square root of 4, over the square root of the denominator, square root of 25. Since you'll be doing the square root, you also have to include the plus and minus in your final answer. So, lucky for us, the numerator and the denominator are both perfect square, so you can actually do the square root of them. So x equals plus and minus, the square root of 4 is 2 over the square root of 25 is 5. So you can leave your answer as x equals plus or minus 2 over 5. So that's going to be your final answer, and let me box that up. And that's basically all you have to do. So again, when you're solving for x and you're using the square root property, make sure to include the plus and minus because you're solving for two answers. Here we have another example. 8 minus 6m squared equals negative 64. Just like any linear equation, you want to solve and get the variable by itself. So the first step, I'm going to cancel out this 8. So I'm going to subtract 8 on the left side, therefore subtract 8 on the right side. Here, when the 8 cancel out, I'm going to be left with negative 6m squared on the left side equal negative 64 minus 8 would be negative 72. Then to get the variable by itself, I'm going to divide both sides by negative 6, the number in front of m squared. So we're going to have m squared equal negative 72 divided by negative 6 would be positive 12. From there, if you're trying to get m squared to become m, the opposite of square is the square root. So square root the left side, therefore I square root the right side. So it's going to be m equal positive negative square root of 12. Now just as you learned from 15.1 and 15.3, you would always check if you can simplify the square root. In this case we can, and here's why. So it's going to be positive, negative. We can break down 12 into two numbers, where one of the two numbers is a perfect square number. So in this case, I'm going to break it down to 4, the square root of 4 times the square root of 3. Because 4 times 3 is 12, and 4 is a perfect square number. So you can actually simplify that. So it's going to be m equal plus and minus the square root of 4 will be 2. You can't simplify or do the square root of 3, so I'm just going to bring it down and put it next to the 2. And that's all you can do. So therefore, this is your final answer. Box that up. So when we're solving and using the square root property, always check if you can simplify the square root at the very end. If you can, do so just like how I did it in here. Break it down where one of the two numbers, one of the two factors, is a perfect square number. And again, the reason I'm using perfect square numbers is because we're using the square root property.